All right. Okay. I think we're live. Hi, guys. Welcome to today's Plumbers of Data Science live stream. Today we're going to talk about MongoDB. I was curious about MongoDB, and I thought let's check this out today. And I have put together a few interesting links that we can check out. And yeah. So if you're new to the channel, this channel is all about data engineering. That means everything that is needed for doing data science and for the data scientists to basically work with the data. And so, yeah, so today with MongoDB, by the way, if you haven't checked out my data engineering cookbook, I'm working on a free cookbook that's on GitHub, available on GitHub. It's about 100 pages right now, so it's all the links from today's stream are also going to be on on the document on GitHub. It's a PDF. You can just download it and make changes if you have some interesting changes. Yeah. So hi guys. Yeah. In one of the previous streams, we were looking at Google Trends, and so I made a screenshot, and of course there's a pop-up in the screenshot, but who cares? We were looking at databases or data storage solutions, and hi Nick, how's it going? So what we have seen is that MongoDB and Elasticsearch are interesting solutions. MongoDB had very much interest worldwide in the last 5 years, so it went up and it's reached a plateau. Same thing for Elasticsearch. And so I thought let's look at it, and I have some links. Some are already in the cookbook, others I'm going to put in the cookbook after the stream. Yeah, whoops, this is the cookbook. Where are my links? Okay, so regarding MongoDB, we have been looking in previous episodes. We were looking at key value stores and such. So how data can be stored. So let's bring up the cookbook quickly. What you can have SQL databases or no SQL database. SQL databases are table oriented, are very, very good structured, and NoSQL databases are basically for storing data in another way. So there's, for instance, key value stores like HBase. Then there are document stores, which as I would say MongoDB is one of them. It's a file storage. And then you have Hive, Impala, Kudu, Druid, InfluxDB, in time series database, and some, and I always forget how MPP is, massively parallel processing database, I think, where Greenplum is one of the things. So, yeah, anyway, MongoDB, it looks interesting, so I thought let's quickly look at it together in this stream. We have to figure out how this stream is going because yeah, the little one is in pain again, and maybe I need to quit at some point and resume tomorrow. But hopefully we can get through it. Yeah. So MongoDB. A quick introduction. What I have found is a interesting site, Guru99, and they have some what is MongoDB introduction and an example. And I thought let's quickly check this. Yeah. So the main thing with MongoDB is you have it's a document store. It's a file store, and it's not in a way that you pre-built tables and you write data into these tables. Basically, every document can have a different structure that you create. Document structure, they say, is more in line with how developers construct their classes and objects, and so it's more in line with processing or with coding, and it's very also very interesting if you're working with JSON strings, JSON objects that are very good structured, for instance logging and so on. So this stuff. As seen in introduction with NoSQL databases, the rows or documents as called in MongoDB doesn't need to have a schema defined beforehand. And this is one of the interesting things for NoSQL databases. That's very, very interesting. And hierarchical relationships. Okay, I don't know this. And then scalability. So they say it's very scalable. I've defined clusters with some of them running 100+ nodes. Yeah. So how MongoDB is storing the thing? MongoDB is using a data or a file system or a storage system based on. I have the link here in there. I haven't pulled this up. I wanted to pull this up later, but now when I get this right now, it's storage in JSON storage format, binary JSON format. This is how the stuff is stored. So yeah, so one example so that we understand how this stuff works is the ID field is added by MongoDB to uniquely identify the document in the collection. So the collection is more or less like the table that you have, and so it's an ID. You can give it one, or it gets one from MongoDB automatically, and then you have your data that is in the document. And this is an example for order processing. So the key is the ID, and then your fields are like the tables in a SQL data. No, not the tables. The columns in a SQL database are then in this case from the object, from the order object, the order ID, the product name, and the quantity. And this is, as you can see, you can then structure this again like a table and search for it. So you have the first thing is the ID, then the collection, that is a grouping of MongoDB documents, equivalent of a table in SQL world. Cursor is a pointer to results of a query. Database database. This is a container for collections. So it's a container for like a database for tables in SQL world. Then you have a document. Document is a record in a collection, and you have the fields. Field and name value pair. So this then here would be a field, customer name, and the value. I think it sounds interesting, and it sounds very simple. Yeah. Then they say, okay, one more thing is JSON. I think we all know this. So the overall structure, I think it's quite understandable, and what you can see is that you can use it in a way like a bit like a SQL database when you structure the stuff or structure the collections, and have the same data in each collection, or the same structure of data. Does that make sense, guys? Yeah, so they say why use it, document oriented, ad hoc queries, range queries, regular expression searches. It can do indexing. They say it's good for it's good because it has good replication and load balancing. what is this? Data modeling in MongoDB. As we have seen in the introduction. Nick, one thing that I think where MongoDB could shine, and as you can see in this article, in this part of the thing here, basically in your the file where your, I think this is called a file, right? ID. The collection. Oh man. Where was that? What you can note is that the order data, which is in our stored in a separate table, while MongoDB is actually stored in an embedded document. So this is one of the key differences. So basically, as I understand it, this you can add documents to a collection, and then this will have the order, or you can add multiple orders in this way, and every order would be every collection would be a file. So if one thing that one of my beefs with HDFS is always the small files problem, and as I understand it, that with MongoDB you can get around this, but I'm going through this with you guys. I'm figuring this stuff out. Also, I'm guessing that a lot of you guys have more experience in this. Yeah, Sebastian says it depends on how you access the access pattern. MongoDB shines when your data is in a document format and you don't care about normalization. You can read the entire document in one read with embedded documents. Yeah, so you can just pump in documents into this thing. It's stored in a binary order, or in a binary manner, and you don't have this freaking small files problem like in HDFS, and especially when you're doing streaming of data. I'm not 100% sure with regarding the access of the data, how easy it is, but I'm guessing we're getting to this. Why is MongoDB? So the differences, okay, table equals a collection, row equals a document. In RVS, the row represents a single implicitly structured data item in a table. In MongoDB, the data is stored in documents. So basically every row of a SQL database could be a complete a huge document in MongoDB. And I think this is where MongoDB could be interesting. Could be interesting to work with. Yeah, data integrity, this is not explicit requirement MongoDB. Yeah, and you don't need to normalize like Sebastian already said. What is it? What's the next thing here? Components of, okay, we're already, is this already finished here? Next. Okay. I'm guessing this was already everything they had for MongoDB. So I found a Hello World example. I can put you the link in the chat. Just a second. I'm going to put it in the cookbook as well. Here's the link to that. So here's another document where you can see how to install MongoDB and create a collection and then insert a record. I'm not 100% sure. Yeah, this basically shows you how to insert, update, find records, and delete records, and also on the topic of indexing, how you find stuff quicker. I was hoping to see more DB table name insert or DB table name save data. So what is this data field here? Because I was hoping that you can add here a, yeah, I Dragonfly, by the way. Okay, let's. Because I was hoping that you have an import here where you can upload a complete file. Let's quickly Google this. Let's quickly Google this. DB table name save a whole file. I don't know. Can't find stuff right now. Maybe we see some answers here. As Sebastian says, you can with Mongo import. Command line utility. Okay, that's not good. So, okay, interesting. So the data you input here, this is it. Basically you input this through code, not import documents. And so I'm guessing that if you're having something like Kafka and Spark, you could write from Spark into MongoDB and add data here. I think I have an example for that. Okay, so this thing is more of a hello world example. What I was looking for, what can you do with this stuff? And one thing that is interesting, if you have a MongoDB, how can you access data? And can you access data with something like a BI solution like Tableau or Power BI? And it looks like there's a way. Nick asked if in JSON as a document it's better to use Elasticsearch. I don't know. The next thing that we need to look at is Elasticsearch, I think. Or try MongoDB out. Rodney says, I wonder if there's someone that codes in Mongo using this difficult syntax, because there are softwares that translate SQL to Mongo syntax. No idea. Yeah, the JSON format is very efficient. It's always whenever you're in binary, you're storing stuff in binary or saving stuff in binary. That's very, very fast, especially for reads. Yeah. Yeah. So they have one thing here that says making MongoDB data look relational. Basically, they have a sample document here. So you have the ID. You can see the. Can we make this bigger? Or even more bigger? No. So you have the ID again and some stuff, and then you have your rows in that. And with that, as you can also see, date, grade, score, this is always the same. Field name, so they are using building. Address building, yeah, they are basically mapping this then. And then you can, what is this thing here down below? Can I move this away? Oh, okay. Come on. So you can make an ODBC connection as it looks like. Database. Can generate a schema for the connection. Schema file. And then, okay, and then you can connect it to something like Power BI. Oh, okay. Okay. Why not? I'm guessing this is very straightforward, because when you're working with JSON and you're using in one document the basically the objects always look the same, then it's like with Hive, then you can form again SQL like structures. It totally makes sense. Okay, let me just quickly check the chat. Yeah. So I want to see some examples. One thing that I had found, and that was, so I have a few links, Spark and MongoDB. I found. When do you Spark with MongoDB? I thought this was different. Maybe I have copied the wrong link. Spark with MongoDB developers can build more functional applications. Blah 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 blah. Okay, this is. Oh man, I think I need to replace this link. This is not the link I was. This is not the link I was looking for. Yeah, this then. I found one thing that was a comparison to something like a time series store. And this is from Timescale, but they had some examples. And how this stuff works. MongoDB methods, document per event. Okay, this is a comparison quickly to this timescale database. Where was that exactly? There you can see some performance. One thing, yeah, because MongoDB has some different ways of accessing data, or where was that? These two methods here, mean and these things here, single group by, double group by, this stuff. So this is what I meant. Mongo naive, Mongo recommended. These are two ways, but what was each? Where was that? Mongo naive. That's already, because there are some different ways of how to write data to MongoDB. But where was that? I thought this was somehow explained here. Or not. I don't care. Let's go further. Smart time series. This article I found interesting. They had some. It's titled "Why You Should Never Use MongoDB." This is interesting. They explain how they had a project and they decided to use MongoDB, and then basically everything was working, and they explained a lot here how this stuff was going on, and then they explain how MongoDB stores the data again and how they stored their data, and it was basically a search for movies, and you had the movies and then the actors and so on inside that, and yeah, with comments, commenter, and likes and so on. And the problem was, where was that? That the customer wanted to access the data in another way. Where was that? It was written a bit fun, also funny. Man. Here. So they say about 3 months in the development, it was still humming along nicely on MongoDB. One day at the weekly planning meeting, the client told us about a new feature that one of their investors wanted. When they were looking at the actors in an episode of a show, they wanted to be able to click on an actor's name and see that person's entire television career. I think you can also already see where this is going. They had MongoDB and they were storing each film, and basically in documents for themselves, and then they were searching on top of it, and they want to be able to click on action. Yeah, they wanted a chronological listing of all the episodes of all different shows that actor had ever been in. Here they say it. We stored each show as a document in MongoDB containing all of its nested information, including cast members. If the same actor appeared in 2 different episodes, even of the same show, their information was stored in both places. And this is something in a SQL database. What would you do? You would create a table where all the actors are, and then you would basically via keys, you would connect episodes and the episodes table, or the episodes table with the actors table, and then you could do queries both ways. You could say which actors are in which episode, or in that episode, or which actor, or this actor in which episodes is he. But in MongoDB, there are no these types of connections are not there. You're just storing raw data. Let's go raw, yeah. And so this type of stuff is very, very hard to do. And as they say here, the information is basically stored in multiple places. So we had no way to tell, aside from comparing the names, whether they were the same person. So to implement this feature, we need to search through every document to find and deduplicate instances of the actor that the user clicked on. Basically, this stuff should run live and very quickly. Yeah, and they basically converted then to PostgreSQL, because in a SQL database this stuff is super simple and very these types of searches are very simple, and yeah, so this is a good point that you need to always look into. Find out how people are querying the data and using the data, and this needs to be very neatly or tightly defined. Usually it's the data scientist, because data scientist, and data scientist talks to the customer, because usually once you're going one route, it's very hard to convert to something else, and you're in this MongoDB case, you're locked in. So always make sure how is the data queried, how is the data used, and find the perfect solution for that. You can write as fast as you want and as scalable as you want. If it doesn't fit to how the data is used or queried, in the end, you're running into a problem. So so they converted, and basically everything was okay, but Sebastian says we started having issues with data integrity. MongoDB is a developer database. Developer can change the data type of property column, change the name of property. There is no schema enforcement. Of course that's a problem. In a SQL database or something, you can't do this on the fly all the time. It's not enforced. Okay, that's interesting. Things inside subdomains in Mongo only exist in the context of that specific document. If you had all the actors inside the movies documents, the actor does not exist outside the movie. But again, it totally depends on how you process the data and what you're doing with the data. So they would have been running okay if the client didn't come up with the idea that he wants to click on an actor and then see all the films that the actor was in. This stuff is interesting. So you can check this whole thing out. I'm going to put the link in the cookbook, and they have this is a good example and an interesting example, because they go in detail how they build up their use case and what exactly were the problems. So this thing, I think this document alone can help a lot of people. What have we? Wasn't there one other comparing it to Influx, or was that? Okay, I added some links to Influx, and I think wasn't Dashboard Spark, Grafana, Influx. I thought I had a link. MongoDB, okay, versus Cassandra. Let's quickly look at this one. Come on. Yeah, who uses this? Of course, everything is used everywhere. It's completely uninteresting. They also quickly explain how this stuff is. When do you use what? So Cassandra, unstructured data, yes. Where's more information? Let's get into Cassandra another time. So you can do indexes. They say these are some examples how to query data. Exactly, Nick. Everything is used everywhere. So this absolutely makes no sense to tell where the stuff is used. Yeah. Interesting stuff is with the who's currently behind the database. So MongoDB started 2007. Mongo from Humongous. That's so it's MongoDB Inc. basically, and Cassandra is open source project. Cassandra is under the Apache, and MongoDB is Mongo. Active community. I think this is not so interesting. Here, use cases. Use case Cassandra real-time analytics, e-commerce, fraud detect. Okay, this stuff also makes no sense. The one thing with Cassandra, basically, Cassandra is a wide column store, so you have you can have millions of columns in one row, and then use this. So it's not about having a lots of rows and basically a large amount of rows, but a small amount of columns. This is the other way around. It's a lot of columns you can have with this one, and it's also not fixed. Fixed in terms of column names and so on. There's no schema needed to be defined before you use it. MongoDB a great choice if you have unstructured and or structured data with a clear definition of the data structure. And this is something that we have seen with MongoDB. So within a document or within a collection, it makes sense that you need to know your format, and you need to keep this format. If you're starting to modify this, then I'm guessing this thing gets out of hand. Yeah. Yeah, and also everyone is an expert. Yeah. Okay. That's already it, guys. I don't have any more. I'm going to give you all the links. I personally find MongoDB an interesting solution. I'm not 100% sure, though, if it makes sense in a lot of cases. I'm guessing that if you already have your data in JSON format because you have something that comes streaming in from an API or from a logging system, then this could make a lot of sense. And yeah, I don't know. Yeah, Nick asked Neo4j. We can make. I mean, we're here. We're completely free here to explore, and I quite like it when we go over tools, and yeah. So this way we can find stuff for beginners and look a bit into it and evaluate a lot of stuff and get a first impression, and then fill up the cookbook and can move forward, and we can also then try stuff out. This it's interesting. Yeah, Neo4j. I heard it mentioned sometimes. Google Trends wasn't that that hype for Neo4j, we can check. Next thing I would say we look into Elasticsearch, because let me bring up again the document. Where was it? No, not this one. That's gone. Here it is. Because as you can see, or not, oh no, you can see. As you can see, or maybe not 100%, Elasticsearch is below MongoDB, but also top of the other things. Lee asks, one thing I don't understand, how do programs that implement SQL type query make it work in a NoSQL environment? So yeah, the thing is always, you bring your data into a I don't want to call it SQL structure, or into a structure where you could create columns back again, like we have seen here with MongoDB. Now, if I can figure out which mouse to use, or this first very simple example, like here. Like here, you have your objects, like your order objects, and these objects can be can vary and don't need to be predefined, but and you can basically store everything you want in there. You can store even bigger stuff with, let's say, 100 columns, and you don't need everything, but you just push everything in, and it's stored as JSON files. And then, because you know the structure, you know that you have order ID, you know that you have one that is called product, you can then basically translate it back again into a SQL style connection. It's the same thing with stuff like key value stores, like HBase. In HBase, you have your composite key. So the key has multiple parts. In this example, for instance, you have a key that then is consists of order ID or customer name, and then the order ID, and then you have this thing behind. And in what you would do then, if you're running HBase and Hive, you would create a Hive table, and you would split your row key back into columns for Hive, and then the columns would be one column customer name, one column order number, and then you're back again into a SQL manner. And this is, I think this is the same here with MongoDB, but you need first, it's flexible, but you need to think beforehand. Yeah. Sebastian says regarding this, basically they reuse the query parser. They parse the SQL sentences in tokens, and then implement the queries in their own language based on their own query interface. I think I don't understand this. They parse the SQL sentences in tokens, and then implement the queries in their own language. Asma says, hey, I'm a student, and even if I don't find MongoDB to be as attractive as I thought, but I find it really nice to know what the options are and could be used, and when MongoDB was always priced. Because pros and cons in every DB. Yeah, that's the idea here. We're not only trying to do one. Right now we have, let's say right now in these streams we have a few pillars. We can do case studies of companies, what companies do. We can do this the course where we are doing the project with Twitter, NiFi, Kafka, Spark, and then stuff like this where we go over tools. Yeah, you guys like this, and people like this. And you don't really find this stuff, and I think it really helps when we put these links into the cookbook. Yeah, let's do one thing at a time, and I think for MongoDB it's interesting. I'm not 100% sure. I'm not 100% sure how to use it in a way where it makes most sense. Because one thing is always how to get the data out. And where was the example with the find? Find records. Find records use criteria. Okay, then you can say this is more like select, find, username, Google, and then you get all the rows. Where this username length smaller than, okay, exists true. Yeah. Yeah, Nick, I'm guessing what I'm guessing where MongoDB could be interesting is streaming log data into these files, and then basically run real-time analytics on top of it. That this would be one case, I think, that would make sense for MongoDB, because as I said, with HDFS, for instance, you always have the problem that when you do streaming data, you run into the small files problem, and you need to compact stuff on HDFS manually. There seems to be a way with Flume, but I'm not 100% sure. So yeah, this seems like a interesting solution for such log processing or something. Because you get the data, you stream it into the MongoDB, and at any time you can find records. And what I'm guessing I would do to not have the small files problem in HDFS, I would push the messages, the log messages into a Kafka, and then in a batch manner every hour or so extract the data from Kafka and put it into HDFS, so you don't have that many small files. So I think for these types, this sounds interesting, but this is more, but nothing for time series. I think for time series, time series, I don't know. Yeah. In the next stream, let's look at Elasticsearch. I'm curious about this. Okay, guys. That was fun. Let me know if you like these small streams where we don't work on big projects, but where we just quickly look into tools and get an overview. What is what and how do you use it? So you guys or beginners can look further. Yeah, that's it. I don't know if yesterday I couldn't come, unfortunately, here because I was at a at a meeting from work. So maybe I do another stream. I don't know, maybe tomorrow. Let's see. I'm going to keep you posted. Hit the like button. Share this stream. And if you want to support what you like, and if you like this, check out my Patreon, where you can become a plumber, like Nick. And yeah, thanks, Nick. Yeah, see you guys. Bye bye.